Hey guys, all right, so we're on day three. We'll do a quick recap uh, where you should be at. I just was texting Mr. Lopez so he knows you guys will have a total of 4 videos and 4 homeworks you have to get done this week. So Friday will just be a kind of a catch all, do whatever you haven't done so far. So we've been talking about this. What we're doing is we're taking a region that we didn't have in geometry like that, and you're trying to find the area of that weird region. And the way we can do that is we can break it up into little rectangles because rectangles are easy to find area of and just add them all up. And sometimes you start your rectangle from the right hand side, other times you start it from the left, and then sometimes you do midpoints, right? And the one yesterday we did trapezoids. So there's lots of different ways to get these areas. And the big concept is that if you want a better estimate, you just have to have more rectangles. And if you start drawing tiny little rectangles like I'm doing right now, you used to think of this as kind of shading in something. Well, you're not. Now those little pen strokes are actual rectangles that are just ridiculously thin, right? And if you had all of those rectangles, like a gazillion of them, the actual area is perfect. Okay. And our calculators can do these types of things, right? We're learning this intro process that first year calc students, right, have to write a passage. You have to understand you can add up rectangles, and the more rectangles you have, the better your estimate gets. And then we leave it behind and we do something called math 9, and we're going to find the actual area. Okay. And so the notes today are super easy. We're just going to roll through some calculator functions, and then it'll be nice and quick. Okay. So on the notes, you got a bunch of disgusting math on your paper with symbols and summations and limits, right? But let's just kind of talk through it because that's really all this is just talking, and let our brain kind of work through this. So we're this big sigma notation is adding stuff up, and you're adding up. We talked about this day one. This is your height, and this is your base, and they're being multiplied together. And so you're adding up a bunch of base times heights, which is just adding up areas of rectangles, right? And then what's up with the limit? Well, we're going from k equals 1 up to some number of partitions. So instead of telling you like, hey, make it 4 rectangles or have 4 partitions, I'm going to take the limit as n approaches infinity. So instead of 4 partitions, we have like 7 or 8 or a gazillion, right? As n gets really, really, really big, that's this picture. Okay. If n is equal to 4, 1, 2, 3, 4, that's this picture. Okay. So all this is saying is it's Greek. As we increase our partitions, it gets to be exact. All right, then what happened? Well, then the Greeks kind of got taken over by the Romans, and then this sigma turned into this elongated s, which is called the integral sign, right? Which you guys have seen before. It's just a notation difference. The limit goes away, and that's what this guy represents. So this is also a summation function, right? It's just math notation for, hey, add up a bunch of stuff. You have to be able to interpret this, right, in words. So when I see this, I know that that says the integral, that's the integral sign, from a to b. So you have two numbers here sometimes. You're starting at a and going to b, so that's why they alphabetize it. So you know to start at the bottom of this function, f of x, and then this guy is with respect to x, right? And so this x always matches, your function. Okay. All right. This picture, that exact notation also represents the area under a curve from A to B, right? And so if we just do some little example here, let's take a function we've been working with a bunch, y equals x squared, and we want to find the area of that. The area of that written in calculus notation is the integral from A to B, if that's B, of that function, x squared, with respect to x. Okay, so the integral from a to b of x squared dx visually is that. So all these things we've been doing, right, is written in that notation. Okay, and sometimes you guys, that area can be above the x-axis and below the x-axis. For instance, what if we did something like y equals x cubed, and we go from -2 to 2? Well, maybe you remember, you guys, these are symmetric. This is a positive area in calculus, and if it's below the x-axis, it's negative. And if they're symmetric, and you went from -2 to 0, and then from 0 to 2, they would cancel each other out. So if you wrote the integral of x cubed from -2 to 2 with respect to x, you're going to get a value of 0, okay, because of that positive area above and negative area below. Okay, and we can do these calculations in our calculator, right? We don't have to actually know how to perform this yet, even though that's coming, right? We can just type it straight into a calculator and see. So let me teach you how to do that just on this little example. All right, so you want to do some integrals. You hit what's called Math 9. So you hit the Math button, and if you look down here at 9, it says fn int. That's going to be your integral. So when you hit the 9 button, up pops your integrand. You're ready to rock. Let's go -2 to 2 of, what do we say, x cubed? I just made this one up, right, with respect to x. And because we know what that graph looks like and the symmetry involved, when I hit enter, I'm going to get 0. And then let me show you visually. So let's go in here. Let's clear out any other functions. And let's change our window. Let's just go from -3 to 3. And if I cube 3, I'm up at 27. So I better go down to -30 and up to 30. So let's just look at our graph of y equals x cubed. Okay, and this kind of looks like what I drew. And there's a way actually in the graphing function to see the integral as well. So let's go back to that calculate button. We've done that before when we calculated intercepts or zeros. Check out number 7. Right down there. There's the integral. Hit it. It's going to start asking you some questions, which is weird because it's a calculator. Lower limit saying, all right, well, where do you want me to start? Well, let's start back at -2 and then hit enter. And then it's going to say, all right, where do you want me to go to? Let's go out to 2. And you'll see, you guys, as soon as I hit this enter button, what the calculator is doing is what you guys did, the Riemann sums, the rectangular approximation methods, just making the number of partitions approach that infinite value to where every little line stroke is a rectangle. Starts to color it all in, and there's your integral that's equal to 0. Okay. Now, it's kind of pretty to see it on the graph, but really what we want to do, you guys, is we want to just use Math 9 on the AP exam because it's much faster. It's eliminating the need to actually get a picture of it. Okay. All right. So let's look at these 4 properties and then actually 2 properties after we practice some Math 9 here. Okay. So all I want you guys to do, and this homework will just be typing it into a calculator. You're just getting used to it. I'm not going to do all of these because it's kind of a waste of time on video, but let's just at least do the first one. So if you want to calculate that in your calculator, you hit Math 9. You enter your lower limit, which is -1 and 2. And then you type in x sine of x. Make sure you guys are in radians, not degrees. And with respect to x. Now, what you guys should know also, right, what we just learned is what is that saying? That is going to calculate the area of that curve from -1 to 2. And so it's probably worth coming in here and pausing. Let's type in x sine of x. You can just watch. You don't have to do this. I'm trying to find the area between that curve and the x-axis from -1 to 2. So I'm just going to change my window. Let's go from -1 to 2 and give ourselves some room here. That is the function x sine x. And you can see, right, that there's some space between that function and the x-axis and then over there. If you want to know the area of that weird shape, you could do rectangular approximations, which no one likes, or you just hit Math 9, and that area is equal to 2.043, rounded to 3 decimals when? Always. That's the only thing the AP exam accepts. Okay, so 3 decimals, 2.043. Okay. All right, let's go in and look at this function here. Let's do 4 over 1 plus x squared. And we're only going from 0 to 1. So we're going from 0 to 1. Let's see what this thing looks like. Nothing exciting. Okay, that's just some random shape. And we can find the area, right, using Math 9. I'm here, so I'm just going to use it this way. If I go into 7 and do 0 and 1 here, It's just going to add it all up for you. You can see it's a bunch of rectangles. Answer is 3.142. So this is 3.142. Okay, I'm guessing you guys can plug in that last one. All right, so let's talk about these two properties, and they're pretty simple and straightforward. They should make good sense. The area from A to A underneath the function will always be 0, whatever the function is. If you go from 5 to 5, right, there's no area. There's no space. You haven't gone anywhere. So this is just straightforward. You don't need to type this in Math 9. If you look at the function y equals x squared and, hey, I'm at 1, let's go from 1 to 1. There is no area there. Even though you could say there's a line, there's not, because that line does technically have a thickness, right? So that area is 0. Okay. And then this one, they use this a lot, you guys. It's not complicated. You just have to remember it. It's just something you memorize. If you go from A to B, you're allowed to switch those bounds, right? Take A and B and switch them. Make it go from B to A. If you switch your bounds, right, you have switched from a positive to a negative. Okay. And so right here, if you look at this function going from 3 to 2, that's just weird, right? We try to go from small to big. So let's rewrite it. Let's go from 2 to 3. Okay. Instead of 3 to 2, I switched them. But if you switch your bounds, you need to switch the sign in front. It was positive, it's now negative. If this was a negative in front, it would switch and become positive.
It's like our COVID results.
Yeah, totally. All right, so then if you do negative, not minus, math 9, from 2 to 3 of the function x squared with respect to x, boom, answer negative 6.3, not 3 repeating, right? Go to 3 decimals, truncate or round, type in your negative sign, your integral, and you're off to the races. Okay? All right, so let me repeat. That was lesson 3. You guys have your homeworks on the calendar. I'm going to do one more video at some point on the next day. And so this week, your goal is to have watched 4 videos and done 4 homework assignments. That's what I'm telling Mr. Lopez too. Okay. Hopefully you guys are being nice to him, and maybe he's telling some good jokes or something. I don't know. All right. Keep it real.